Hi friends, welcome to the next video. We shall solve some very important problems on joint PDF and joint CDF respectively. I shall be sharing this material with you on WhatsApp shortly so that you can go through the material along with the video lectures when you are going to study. The problems, first problem statement goes like this. The joint PDF fxy of x comma y is equal to c, where c is a constant when 0 less than x less than 3 and 0 less than y less than 3 and is 0 otherwise. That is fxy of x comma y is equal to c, where c is a constant for x lying between 0 and 3 and for y lying between 0 and 3, and fxy of x comma y is equal to 0 otherwise. So I have to calculate the value of the constant c. I have to find the marginal PDFs for x random variables x and y respectively. That is, I have to find fx of x and fi of y respectively. Please note it is PDF. So small fx of x, small fi of y I have to calculate. Then I have to find the corresponding joint CDF when 0 less than x less than 3 and 0 less than y less than 3. And I have to find capital fxy of x comma infinity and capital fxy of infinity comma y. Then I have to check for the independence. That is, I have to check if x and y are independent. So these five I have to calculate. Normally this problem would be asked for 10 to 15 marks in the examination because little bit of mathematical computation is involved, and here and there we will be doing double integration and single integration also. Now I have to find the value of the constant c. First we shall go step by step. I have to find the value of the constant c. So in order to find the value of the constant c, I have to assume that fxy of x comma y is a valid or a legitimate joint PDF or bivariate PDF. So for that, the condition for a joint PDF to be told that it is a legitimate or a valid joint PDF is that it must satisfy the criteria that the area under the fxy of x comma y curve should be equal to 1, or integral minus infinity to plus infinity, integral minus infinity to plus infinity, fxy of x comma y dx dy should be equal to 1. That is, double integral minus infinity to plus infinity, fxy of x comma y dx dy should be equal to 1. But by data, fxy of x comma y is equal to c for x lying between 0 and 3 and for y lying between 0 and 3. For all other values, it is equal to 0. So substituting the limits, I get integral 0 to 3, integral 0 to 3, c dx dy is equal to 1. Now c is a constant, so I can pull it outside the double integral. And apart from that, this is a iterated or a repeated integral. Please remember your M1, M2, right? So a double integral can be split into the product of two one-dimensional integrals here. So this gives me c into integral 0 to 3 dx, integral 0 to 3 this can be split as c into integral 0 to 3 dy into integral 0 to 3 dx. The first integral is with respect to variable x. The outer integral is with respect to variable y. Please note. The inner integral, this is how we split it. So I get c into integral 0 to 3 dy, integral 0 to 3 dx is equal to 1. I am splitting this into the product of two one-dimensional integrals. That is, a two-dimensional integral or a double integral is being split into the product of two one-dimensional integrals. So I get c into integral 0 to 3 dy, integral 0 to 3 dx is equal to 1. Or integral dy is equal to y, integral x is equal to integral dx is equal to x. So I get c into y limit 0 to 3 into x limit 0 to 3 is equal to 1. Simplifying, I get c into 3 into 3 is equal to 1, or c is equal to 1 by 9. So I need to substitute c here. So fxy of x comma y is equal to 1 by 9 for both x and y lying between 0 and 3 respectively. Okay. So I have to substitute the value of c. So the first part of the problem has been solved. Now coming to the second part, I have to find the PDFs of x and y. So here I should be very, very careful. PDFs of x comma y means, PDFs of x and y means I have to find the marginal PDFs. I have to find fx of x and I have to find fi of y. That is what I am calculating. Small fx of x, small fi of y. So I am PDF for random variable x is simply given by fx of x is equal to integral minus infinity to plus infinity fxy of x comma y dy. But here it is not, I am calculating the PDF for random variable capital X, but that is given in terms of the integral fxy of x comma y fxy of x comma y dy with limits y ranging from minus infinity to plus infinity. x ಕಂಡುಹಿಡಿತಾ ಇದೀವಿ, ಬಟ್ ಇಲ್ಲಿ ಇಂಟಿಗ್ರೇಷನ್ ಅಲ್ಲಿ y ಬರುತ್ತೆ. ಇದೇ ಹುಷಾರಾಗಿರ್ಬೇಕು ಅಂತ ಹೇಳೋದು. Now y has got a non-zero value of c equal to 1 by 9 only for y lying between 0 and 3. So that's why this integral minus infinity to plus infinity for y becomes integral 0 to 3 c dy. So substitute the value of c which we have calculated. So 1 by 9. So fx of x is equal to integral 0 to 3 1 by 9 dy I get. Now integrate. So 1 by 9 is a constant. I can pull it outside. I get 1 by 9 integral 0 to 3 dy or 1 by 9 into y limit 0 to 3. So substituting I get fx of x is equal to 1 by 3. 1 by 9 into 3 I get. So cancelling I get 1 by 3. So this is the marginal PDF. Fx of x is equal to 1 by 3 for 0 less than x less than 3. Similarly, this is the PDF for random variable x. This is the marginal PDF of x. Now I shall find the marginal PDF of y. So fy of y is given by integral minus infinity to plus infinity fxy of x comma y dx. Please note, I am evaluating the marginal PDF from the giant PDF. So that's why I should write small f only. Now again, x ranges from 0 to 3. Why? Because for x lying between 0 and 3, fxy of x comma y is equal to a non-zero value equal to 1 by 9. So that's why this integral minus infinity to plus infinity, this integral minus infinity to plus infinity gets reduced to integral 0 to 3 fxy of x comma y dx, which is equal to integral 0 to 3 c dx. Substitute c is equal to 1 by 9. Simplify. I get fy of y is equal to 1 by 9 integral 0 to 3 dx. So substituting and simplification yields fy of y is equal to 1 by 3 for 0 less than y less than 3. So second part of the problem is over. Now coming to the third part, I have to find the giant CDF now. These are all definite expected questions in your final examination. So please lay more impetus on it. I have to find the giant CDF for 0 less than x less than 3 and 0 less than y less than 3. A giant CDF is also called the bivariate CDF. So that is simply given by fxy of x comma y is equal to integral minus infinity to x, integral minus infinity to y, fxy of x comma y dx dy. Very, very important formula which you need to remember. Very, very important formula. Without remembering the 18 formula, we cannot solve this module at all. It's very, very important to remember this. So the bivariate CDF is simply given by fxy of x comma y is equal to integral minus infinity to x, integral minus infinity to y, small fxy of x comma y dx dy. But my next step would be to check for the limits. What is the lower limit of x? What is the lower limit of y? By data, the lower limit of f of x is 0, the lower limit of y is 0, as given in the problem. So due to this, the integral minus infinity to x, integral minus infinity to y, fxy of x comma y dx dy reduces to integral 0 to x, integral 0 to y, fxy of x comma y dx dy. Because as per the given problem, the lower limit is 0. So see the change, how it has been done. This is as per the given problem definition, isn't it? Now substitute the value of fxy of x. So integral 0 to x, integral 0 to y, I get c dx dy. This is again as per the problem definition. C is given by 1 by 9 as we have calculated in the first part. So I get fxy of x comma y CDF, giant CDF is given by integral 0 to x, integral 0 to y, 1 by 9 dx dy. 1 by 9 is a constant, so pull it outside. So I can write this as 1 by 9 integral 0 to x, integral 0 to y dx dy. Now this can be split as the product of two one-dimensional integrals. This double integral can be split as the product of two one-dimensional integrals. But be very, very careful. Very, very careful. Normally, confusion arises here. Confusion ಹೇಗೆ ನಾವು ತಡೆಗಟ್ಟುಕೊಂಡು ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಅನ್ನೋದೇ ಈಗ ಇರೋ ಪ್ರಶ್ನೆ. ಅದಕ್ಕೆ ಉತ್ತರ ಇದು. 1 by 9 integral 0 to x, integral 0 to y dx dy. So this can be written as the product of two one-dimensional integrals. So 1 by 9 into integral 0 to x dy, integral 0 to y integral 0 to y dx. So 1 by 9 integral 0 to x dy integral 0 to y dx. Now integral dy is y, integral x is integral dx is x. So this becomes integral 1 by 9 into y limit 0 to x into x limit 0 to y. So substitute the lower and the upper limits. I get 1 by 9 into x minus 0 into y minus 0. Or the giant CDF capital fxy of x comma y is simply given by xy by 9. That's all. ಇಲ್ಲಿ ಹುಷಾರಾಗಿರಬೇಕು. Next, I have to find fxy of x, capital fxy of x comma infinity and capital fxy of infinity comma y. ಅದೇ ತರ ನಾವು ಕಂಡುಹಿಡಿಯಬೇಕಾಗಿರೋದು. Look, let us come into that part of the problem. What are fxy of x comma infinity, capital F, to be more specific, and capital fxy of infinity comma y? Now, capital fxy of x comma infinity is nothing but fx of x. Remember equations 5, 6, 7, 8, so on and so forth. So using in the previous lecture that we discussed. So fxy of x comma infinity is equal to fx of x, right? Or fx of x is equal to fxy of x comma infinity. Now I should be very, very careful here. Fxy of x comma infinity I have here. This is the mathematical definition. But this infinity will get replaced by the upper limit of y as per the given problem. ಇನ್ನೊಂದ್ಸರಿ ಹೇಳ್ತೀನಿ, ದಯವಿಟ್ಟು ಸ್ವಲ್ಪ ಹೆಚ್ಚು ಒತ್ತು ಕೊಡಿ ಇಲ್ಲಿ. ಹೆಚ್ಚು ಒತ್ತು ಅಂದ್ರೆ ಹೆಚ್ಚು ಇಂಪಾರ್ಟೆನ್ಸ್. By definition, as we saw in the previous lecture, capital fx of x is equal to fxy of x comma infinity. Or I have got fx of x is equal to capital fxy of x comma infinity. Now infinity is the upper limit, minus infinity corresponds to the lower limit. In mathematically, theoretically, in the generic definition, in a general definition, this is the general definition. In the general definition, minus infinity would be the lower limit, plus infinity would be the higher limit. But now this infinity, which is the upper limit, will get replaced by the upper limit as given in the problem definition, right? So here fxy of x comma infinity. So what is infinity is this fx of y. So y at this is y is equal to infinity. Now this y is equal to infinity would get replaced by the maximum or the upper limit of y which has been given in the problem. ನಾನು ಡೈರೆಕ್ಟ್ ಆಗಿ ಇನ್ಫಿನಿಟಿ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋದಕ್ಕಾಗೋದಿಲ್ಲ. ಇದು ಜನರಲ್ ಡೆಫಿನೇಷನ್. ಜನರಲ್ ಡೆಫಿನೇಷನ್ ಇಂದ ಈಗ ಪ್ರಾಬ್ಲಮ್ ಸ್ಪೆಸಿಫಿಕ್ ಆಗಿರೋ ಡೆಫಿನೇಷನ್ ನಾನು ಬರಬೇಕು, ಅದನ್ನ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಈ ಜನರಲ್ ಡೆಫಿನೇಷನ್ ನಾನು ಪ್ರಾಬ್ಲಮ್ ಸ್ಪೆಸಿಫಿಕ್ ಡೆಫಿನೇಷನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಕನ್ವರ್ಟ್ ಹೇಗೆ ಮಾಡ್ತೀನಿ? It is fxy of x comma infinity, which is equal to fxy of small x. Small x would remain as it is, but now this infinity would get replaced by the upper limit of the as given in the problem corresponding to the random variable y. But how to get that? That is given in the problem statement. 0 less than y less than 3. For y, 0 is the lower limit, 3 is the upper limit. So that fx of x comma infinity would get replaced by fx of x comma 3. Because the upper limit of y is 3. So here is where we should be a little bit careful. So that's why I get fxy of x comma 3 as the upper limit for random variable y is 3 by definition. You can see the problem statement just as I have shown you. So that's why this becomes fx of x is equal to fxy of x comma infinity equal to fxy of x comma 3, which is equal to integral 0 to x integral 0 to 3 c dx dy. This is equation 1 or 2 of our previous video. Now c is equal to 1 by 9, substitute. I get fx of capital fx of x, that is the marginal CDF, marginal CDF, fx of x, capital fx of x is equal to integral 0 to x integral 0 to 3 1 by 9 dx dy. Or 1 by 9 is a constant, so pull it outside. So this is equal to 1 by 9 integral 0 to x integral 0 to 3 dx dy. Or this becomes 1 by 9 into integral 0 to x dy into integral 0 to 3 dx. So integral dy is y, integral dx is x. So this becomes fx of x is equal to 1 by 9 into y limit 0 to x into x limit 0 to 3. So this becomes 1 by 9 into x minus 0 into 3 minus 0, which is equal to 3x by 9. So that's why cancelling 3 and 9, 3 ones are 3 threes are. So I get capital Fx of x, that is the marginal CDF, is given by x by 3. Now I have to calculate. So for the first part of the fourth computation is over. Now I have to find fx y of infinity comma y. So fx y of infinity comma y is nothing but fy of y only. So again, this is a general definition. Now I need to convert the general definition into the actual definition as per the problem statement. This is what I am going to do, as we did for the previous case. So I can write capital Fy of y, which is the marginal CDF for random variable y, is equal to fx y of infinity comma y. Now it is fx y of infinity comma y. So here y would remain as it is. In the capital Fx y of 3 comma y infinity comma y, I am going to replace infinity by the upper limit of random variable x as per the given problem. But this y would remain as it is. So now what is the upper limit of x? What is the upper limit of x? See the problem statement. The upper limit of x is 3, 0 less than x less than 3. So that's why fx of infinity comma y would get replaced by fx of 3 comma y. Fx y of infinity comma y. This is the general definition. Now this needs to be replaced by the actual upper limit as per the given problem with respect to random variable x. Okay, because by formula fx y of infinity comma y is equal to fi of y. That is given by fx y of 3 comma y, because the upper limit for random variable x is 3. So that's why I get fi of y, which is the marginal CDF, is given by fx y of 3 comma y, which is given by integral 0 to 3 integral 0 to y c dx dy. C dx dy. Very very important. ಇದು ಇಲ್ಲಿ ಕರೆಕ್ಟಾಗಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ಸಾಲ್ವ್ ಮಾಡೋದು ತುಂಬ ಈಸಿ, ಬಟ್ ಇಲ್ಲೇ ತಪ್ಪು ಮಾಡಿಬಿಟ್ರೆ ಫುಲ್ ಮಾರ್ಕ್ಸ್ ಔಟ್ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಹುಷಾರಾಗಿರ್ಬೇಕು. ಇಂಟಿಗ್ರಲ್ 0 to 3 integral 0 to y c dx dy. Now evaluate. So this is equal to integral 0 to 3 0 to y, substitute c is equal to 1 by 9, so 1 by 9 dx dy. Or this is equal to 1 by 9, 1 by 9 constant, so pull it outside, so I get 1 by 9 integral 0 to 3 integral 0 to y dx dy. So this becomes 1 by 9 integral 0 to 3 dy into integral 0 to y dx. I am splitting this double integral into product of two one-dimensional integrals, that's all. So this becomes 1 by 9 into y limit 0 to 3 into x limit 0 to y, because integral dy is dy, integral dx is equal to x. Now this becomes 1 by 9 into 3 minus 0 into y minus 0, which is equal to 3y by 9, or cancelling 3 and 9. So I get capital Fy of y is equal to y by 3, which is the marginal CDF for random variable y, capital Y. ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋದೇ ಇರೋದಿಲ್ಲ. ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಕರೆಕ್ಟಾಗಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡು ಹೋಗಿ ಇಂಟಿಗ್ರೇಟ್ ಕರೆಕ್ಟಾಗಿ ಮಾಡ್ಕೊಂಡು ಹೊರಡಿದ್ರೆ ಆರಾಮ್ಸೆ ಬರುತ್ತೆ ಸೊಲ್ಯೂಷನ್. ಸೊ ಅದಕ್ಕೆ ಇದನ್ನ ಈ ಪ್ರಾಬ್ಲಮ್ಸ್ ನೀವು ಒಂದು 5 ಸರಿ ಸಾಲ್ವ್ ಮಾಡಿ ಒಂದೊಂದು ಪ್ರಾಬ್ಲಮ್. Next, I have to check whether this is independent or not. Are x and y independent? I have got the marginal PDF fx of x to be equal to 1 by 3. Marginal PDF of y, small fy of y is to be equal to 1 by 3. Multiply fx of x into fi of y. So I get fx of x into fi of y is equal to 1 by 3 into 1 by 3, which is equal to 1 by 9. But this is 1 by 9. But what is fxy of x comma y? Yeah. fxy of x comma y is also equal to 1 by 9 for 0 less than x less than 3 and 0 less than y less than 3. So that's why fx of x into fy of y is also equal to 1 by 9. Similarly, fxy of x comma y, that is the joint PDF is also equal to 1 by 9. Giant PDF is given by C equal to 1 by 9 for 0 less than x less than 1 by 3 and 0 less than y less than 1 by 3 as per the given problem statement. And the product of the marginal PDFs, that is fx of x and fi of y, is also equal to 1 by 9. 1 by 3 into 1 by 3, 1 by 3 the whole square is equal to 1 by 9. So that's why fxy of x comma y is clearly equal to fx of x into fi of y, which is which are both equal to 1 by 9. Hence, I conclude that the random variables x and y are independent. If this is not true, then it is not independent, it is dependent. Since fxy of x comma y, there is a giant PDF is equal to 1 by 9, and also the product of the marginal PDFs is also equal to 1 by 9. That's why I conclude that fxy of x comma y is equal to fx of x into fy of y. That's why both random variables are independent according to the given problem. If this is not, then it would be definitely dependent. But in the given problem, it is independent. So with this, I shall wind up this video. Other set of problems we shall solve in the next video. Thank you.